Good afternoon, class. Good afternoon. My name is Mr. Taylor. I will be your teacher for the class today. Since we have a assigned seating, I can look over the class and see that everybody is present today. In this unit, we will be covering slopes, linear functions, and equations of a straight line. Although that many of you, if not all of you, are familiar with some of these concepts, so this particular lesson may serve as a review for some of the upcoming lessons. Before we get into the lesson today, I have a short pre-test for you. It's going to take about, I'm going to give you about 10 minutes to complete. It's for diagnostic purposes, so just do the best you can. Did everyone get a pre-test?
We should every train. Yeah, train like yeah. So everyone should 5 minutes. So we finish before 2:55. 25 minutes. Start your diagnostic test.
Oh.
Since you have time, let me know. I'll come back to them. Raise your hand. still want more chance. Everybody still want a chance? You do a choice. Good. Sound good, you good? Good. Need some more time? Yeah, sure. Okay. Today we will be discussing slope of a straight line. And our objectives for this lesson is going to be, we're going to define what a slope is. We're going to determine if the slope of a line is positive or negative. We're going to express the slope of a line as a fraction, and we're going to learn how to compute the slope of a line containing 2 points and given the coordinates of each point. And the essential question that we hope to answer today is, what is the importance of slope in everyday life? First of all, what do we know about slope? Can anybody give us some examples of slope in everyday life? Anybody?
Skiing.
Driving up a hill?
Skiing.
Skiing? Any more examples? Going up a mountain, okay. How about a treadmill? Yeah. The treadmill allows you to adjust the incline to simulate jogging or walking up a hill. How about walking up a flight of stairs? And the elevation gradually changes as you make your way up or down. How about a golf course? A lot of slopes on a golf course, you think? Huh?
I've never been.
Anybody play golf? Anybody ever watch golf on TV?
I played on my Wii.
Yeah, but if you ever watch golf, if you notice the immediate ground area surrounding the placement of the hole is never completely flat. It's never flat and level. It's always a gradual incline or a decline. And golfers have to take that into account when they're trying to put into the hole. Because it's either the incline will cause the ball to either roll away from the hole or roll towards the hole. And those are just some examples of slopes. And I'm sure you can think of some more. But let's move on. So simply put, slope is the steepness of a line. And mathematically speaking, the slope is the change in the vertical direction, which is called the rise, over the change in the horizontal direction, which is called the run. So that's what we're going to be talking about today, the rise over the run. And here's an example. If you have a line, like so, we can arbitrarily choose any starting point on the line, and the slope will be the distance in the vertical direction over the distance in the horizontal direction. And if we move up in the vertical direction, that's going to be positive. If we move to the right in the horizontal direction, that'll be positive. We can also move down in the vertical direction and move to the left in the horizontal direction. If we move down in the vertical direction, then the vertical distance will be negative. And if we move to the left in the vertical direction, then the horizontal distance will be negative. Does everybody understand what I'm talking about? That represents the slope of this particular line. Okay, now I have a couple of activity sheets that I'd like to give out to you guys. I'm going to give you 10 minutes to work it, and it's going to be demonstrating the slope of the line. raise your hand. Yes. Oh. supposed to be working on this independent also. Time is up. Let's go to did I finish? How many people are still working? Okay, I'll give you a couple minutes. Let's go ahead, class, and pass along. We can revisit this at a later date. All right, now that we know how to compute the slope, let's take a look at computing the slope of a line passing through 2 points where we got coordinates in here. And here's an example. And this is just an example of a line passing just say it passes through -2, -1, and 1, 3. And let's just say this line passes through these 2 points. And this is 1, 3. Okay. I want you guys to write down this formula. M stands for the slope, is equal to y of 2 minus y of 1 over x of 2 minus x of 1. So the slope defined this way is going to be the second coordinate of the second point minus the second coordinate of the first point over the first coordinate of the second point minus the first coordinate of the first point. I want you to write that down, because we're going to use that formula to compute the slope of this line passing through these 2 points. And the points are -2, -1, and 1, 3. So let's just plug those numbers into this. And we can just arbitrarily choose which point that we want to be the first point and the second point. So let's choose 1, 3 to be the second point. So if we plug these numbers in, the second coordinate of the second point, which is 3, minus now we need the second coordinate of the first point, which is -1. So it's 3 minus a -1 over the first coordinate of the second point, which is 1, minus the first coordinate of the first point, which is -2.
He was ahead, man.
Oh, actually, that should be minus. This simplifies.
You can stop it, Solomon, man.
What's going on?
Throwing things back here.
What's going on?
I don't know, he's just throwing stuff back.
Oh,
Something back there, solid.
That's a pretty
I'm not
good
trying to
throw.
snitch on you.
it was him. Okay, I don't know who it was, but please don't do it again. We can't have any instructions in class. Don't do it again.
He's got a good arm on it. That's great.
Okay, so we have 3 plus 1 over 1 plus 2, which is 4 over 3. So the slope is equal to 4 over 3. Any question? Anybody see how I did that?
What's M again?
I'm sorry?
Well, we got M, I don't see.
M is the slope. M is just a letter that stands for the slope. Okay? Any questions?
How do we get the Y's?
The y's?
Uh-huh.
Well, as I said before, the y is the second coordinate, and the x is the first coordinate
Of what?
of a point in a Cartesian coordinate system. In a coordinate system, every point is represented by a first component and a second component. And the first component is represented by x, and the second component is represented by y. This should be reviewed from a previous lesson that we already did about plotting points in a coordinate system. That's something we've already been over. Yes, sir.
Yes, sir. What do you mean by components? Is it tools? Components.
I'm
So
sorry.
how do you say components? What do you mean by that?
He can
Is
sit
it
outside.
tools?
Just sit down.
I don't understand the question.
You said component. I don't know what's the meaning. Do you mean electrical tools?
Nobody understands him anyway, man.
All the way from that one, too.
Component. He understands that.
You have one saying component? I don't understand what you mean by that.
Okay, any more questions?
Sir, you didn't answer me.
Eric,
If you had 4 over 3, can you reduce it to 2?
no.
It would have to stay 4 over 2?
This is 4 over 3.
No. If, in another scenario.
No. If it was 4 over 2,
Yeah,
yes, you can reduce it.
okay.
Any more questions? No?
Yes, sir. Since it's a slope, can somebody fall from it? Say it's a slope, can I fall down from it?
That'd be a joke.
Told me it's a slope. That's what your definition.
You hit me
You
with
said
that
a
paper
slope.
earlier, man.
I don't know. My daddy told me that I fell down from a slope the other day.
Well, this just represents the slope of the line. This just represents the slope of the line. This is not the slope of a hill or a cliff. It's just the slope of the line. Okay. At this point, if there are no more questions, right? Okay. I'd like for you guys to take out a sheet of paper. I want you to complete the slope. I got a couple of problems. It's only like 2 problems. It's only gonna take us
Son,
2
yeah,
minutes.
keep hands to yourself, son.
Why is looking
Son.
back?
Son, no,
Why is looking back?
you better stop now.
He's
Better slow
looking,
down,
he's
homeboy.
looking back instead of looking at the board. What did I do to
You
you?
need to slow down. Son, you need to slow down.
I know.
Looking at the board, looking at the board. You need to slow down, man.
I got it. Have a seat.
Move my seat, excuse me. Excuse me. Can I move my seat to the table? Can I move my seat? There's gonna be some problems. I just better move. I gotta go somewhere else.
Yes, you can move. You can move over there. I don't know.
Why did you move?
Oh, what? How can I get this seat, man? This side or something?
No, you got it. You said you could sit anywhere, right?
Sound is crazy. Sound is crazy. Sound take a piece of paper out. You want to see it?
Yeah, take out a sheet of paper. I'm gonna.
Is my name crazy?
Give you a
Is
couple
that my
problems to
name?
work.
Calling me out now? See how you take him out? Is my name crazy?
Class.
Okay,
The
take
noise
this
level is
outside.
it's too loud here.
That's a small world. It's a small world.
Okay. Can you all read this? We have a straight line passing through 2 points. The coordinates are given. I would like for you to compute the slope of this line using that formula, the line that passes through these 2 points. And the coordinates of the points are -4, -4, and 4, 3. I give you like 1 or 2 minutes. Please. Yes, that's good.
Is that -4, -4?
Yes, -4, The points are -4, -4, and 4, 3.
When you minus 4, what is remaining? What will be the remaining one? When you will minus everything, what is going to remain?
Well, these are just the coordinates. It's not an operation. It's not an operation. All right, are we done?
Isa is not doing anything. Keep on peeping. He's cheating. Isa is cheating. Look at him cheating.
It's my business. It's my business. It's like I moved over here, I don't have a problem. It's my business. Solomon.
What do I do?
So
You are cheating.
what do we get for this problem?
I got -7 over 8.
What we got?
I got -7 over 8.
Anybody else?
-8.
What?
I know I'm right.
Anybody else? What do we get?
We got seven.
Seven over eight.
Seven over eight.
It's a minus, right?
I got a negative eight. I got. You know what?
I got some.
I got two minuses, I'll make a minus, right?
Anybody get 4 over 3? Yeah.
No. Negative eight. Double minus.
Well,
Negative eight over one.
I got 0. 0, I got 0.
Everybody done? Let me work this one out on the board right quick, since everybody got me, everybody from there, they got the wrong answer.
I thought I had the right answer.
I know I got the right answer. Negative eight.
It's minus 7 eighths, right?
Negative eight.
Don't feel bad, I got it.
That's what it
But I
is.
think you're right.
You wanted to.
Okay, let's try 7.
Wait, you gonna work? You gonna work?
Well, what was the
I thought you were gonna work it
answer?
out.
Negative eight, right?
What, you gonna work?
No, the answer is 7 over 8.
This is negative.
So let you dig it. Okay,
Wait,
all right.
you're not gonna go over it?
Huh?
We're not gonna go over it?
We're running out of time, so we're gonna have to revisit this on another date. Collect you did get the right answer, was 7 over 8.
Is it 7 over 8?
So let's go ahead and wrap this up. Today we talked about slopes, we learned how to compute the slope. And, we discussed some, examples of slope in everyday life. And some of the professions that, use slope, it is, everyday, integral part of their, jobs, architecture, landscaping, building and construction and whatnot. And, the next lessons coming up, the next several lessons coming up, we'll explore the application of slope. Okay.
Crime right here. Crime right here.